Good morning. Welcome back to session 3 of the PENC Raleigh seminar. Thanks for being with us. We are going to take questions as we go for this presentation, so please type those in at any time. I will read those out loud to our speaker. So again, type those in anytime throughout the presentation. Today's speaker is Tom Bartlett, founder and president of Aquatech Systems and NWA Utility Services, Inc. As a highly accomplished visionary entrepreneur, Tom Bartlett's experience in the domestic and international markets include new business development, key account management, consultative and solution sales, as well as networking and alliance building. Coupled with his personal concern for the environment, his business experience led him to become the founder of Aquatech System, Inc. and NWA Utility Services, Inc. With projects completed throughout the U.S., his operating premise was to provide the resources necessary to assist the private sector in meeting the needs for increased and improved wastewater systems infrastructure. Focusing on both emerging growth areas and retrofitting failing septic systems in rural communities, his company has developed a strong and reputable national presence. Having 22 years of industry experience, his understanding of the regulatory and political influences driving the concept of decentralized wastewater has positioned him as a leader in the innovation, technology, and political influences which support and drive the market. Tom, thank you so much for being with us.
You bet. Thank you very much. My pleasure. I appreciate everybody attending this and giving us an opportunity to present our decentralized sewer concepts and system. I would like to start out today by going through an article that we have put together back in 2007 on decentralized wastewater treatment. We don't actually have a PowerPoint presentation as others may have. We have tried to make our website as interactive as possible, and everything that we send to people and we talk about is on our website. This is an article that was put together back in 2007 regarding decentralized wastewater treatment, or as it's maybe even more commonly called today, a community sewer system. That actually is our website, communitysewer.com. So we do use community sewer quite a bit. And again, please, as we do this, would you please ask any questions that you would? It helps the presentation go smoother and make sure that we cover everything that you feel like covering. That's very important. I will be reading probably most of this article, maybe not all of it, but most of it. You can see this, but I'll read it and you can follow along. Some of this I will skip and start a different area. In this report, I present the economic benefits of small-scale sewage plants, the cost per home, which generally is around 2,500 to 3,000 gallons per day, or dollars per home. The difference in the costing on this depends on the size of the homes, the number of homes, and so forth. The economy of scale, the larger the system gets, the less per home it is. With the cost comparison of decentralized sewer compared to like a large centralized wastewater treatment plant, there's quite a bit of difference. So we are going to talk today about collection, which we offer a different low pressure type collection system, the treatment plant, and then discharge. And most of our discharge is through drip irrigation. It doesn't have to be that way. We can discharge to water bodies, surface water. We can discharge through leach fields if that is what you prefer, or if your state allows a spray field, we can discharge through spray as well. Most of what we do, again, is drip irrigation, subsurface drip irrigation. With respect to the sewage treatment, decentralized solutions can often yield better environmental benefits as well. By treating the water upstream, neighborhood assets requiring irrigation can receive the treated discharge, which in turn percolate underground and help refill aquifers. Large-scale sewage treatment plants are often unable to make use of the treated water. Instead of being recycled and returned to the aquifers upstream, much of it is discharged into rivers. We definitely are losing a lot of our water large wastewater treatment plants. I'm in the Northwest Arkansas area, and we have large wastewater treatment plants that are discharging millions and millions and millions of gallons to rivers, and we're not able to reuse that water in our local area where it is generated. Our biggest challenge, one of the biggest challenges to implementing comprehensive land use plan is how to accommodate new development in locally designated growth areas that do not have public sewers. Many rural and suburbanized towns in the US face this question. A lot of the growth today is urban sprawl and properties. One of our benefits to developer is the properties that are next to the urban sprawl, the large pipe, large pumps, large treatment plants, is very expensive. So just one of the advantages is being able to, the developer going out and purchasing property a mile, 2 miles, 3 miles out of town, and still being able to get the same amount of homes through decentralized sewer, collection, treatment, and discharge all on the same property. And it allows him to, the tax base for the community that they're building in will grow because there'll be more homes per acre in the rural area, as well as they're going to have wastewater treatment to a high standard. They're going to be doing away with septic systems. And as I'm sure most of you know, it's not if a septic system fails, it's when. We do a lot of retrofitting on existing septic systems in communities, which we'll talk about a little later. But so the developer is able to take a system like this and put it a little bit out of town. His property will be less expensive. He'll be able to get as many homes per acre as possible, and the wastewater treatment will be very clean. Communities want to direct growth to the most suitable areas of town, usually near existing services such as fire stations and schools, for example, but have no prospect of gaining access to public sewer lines. New development must rely on soils, usually on a lot-by-lot basis, to handle wastewater. The conventional wisdom says that that means low densities of development, negating the effectiveness of growth area. This is a wastewater treatment plant that is about 200,000 gallons a day. This is in a community, as we're talking about. Has a UV disinfection behind it. If you can see the stainless steel boxes, that's UV disinfection. So this treatment is very, very high standard. Towns and counties without public sewers have options that they may not realize. Additionally, watersheds in the United States reflect tremendous diversity of climatic conditions, geology, soils, and other factors that influence water flow, flora, and fauna. This is equally great variation in historical experience, cultural expression, institutional arrangements, laws, policies, and attitudes. With regards to wastewater issues, it would be a mistake to impose a standard model from a federal level to address the needs on a local level. Correspondingly, centralized sewer systems are aging, frequently underfunded with respect to replacement costs, and expensive to maintain. In addition, centralized sewer strategies are increasingly challenged by environmental and social considerations such as interbasin transfer issues, aquifer depletion, nutrient loading, and urban sprawl.
We have a question.
Yes.
It says, I assume that the $2,500 to $3,500 per home is the initial cost. What is the annual maintenance and operational cost per home?
Well, that's a good question. We also have an operations company, and what we're finding is, again, depending on the size of the system, we do systems that are 10 homes, we do systems that are 200-300 homes. The larger the system, the less per home it is. We are visiting our operation and maintenance people are visiting a site about once a week, depending on the technology, depending on what the effluent standard is. So we're operating here locally right by us about 9 systems. And The operation for each one is different. We do have a couple different technologies, but mostly this one. And we're finding that we're charging about $45 per home, some 50. And we're finding that there is about a 65 to 70% cost within that. So if you have a couple hundred homes, if you're charging let's say $50 per home, it's about $10,000 per month. Depending on everything, you're probably around $6,000 per month regarding everything within our company. So it's not actually just going out and doing it. We include all of our insurances and everything as a company. So, you know, you're probably talking about maybe $6,000 per month, which would be around $70,000 a year for 200 homes, approximately, if that helps answer your question. Is that it, Nicole? Or, okay.
Yes, that's everything.
Okay. And again, that does vary. It's hard to put a number on it, but that's just an approximate. That does vary. Decentralized wastewater management has potential to be the catalyst for the recreation of our institutions to support a new agenda and rapidly building a flexible infrastructure to sustain the integrity of our natural systems that are essential to a healthy economy. I'm going to skip down a little bit. A 200,000 gallon per day off the grid plant can be constructed at a cost of like $3,000 per home. That is the complete treatment system as you're looking at it on the process drawing right here. In fact, let me actually take you to a different drawing, if I might. I believe it is on this page. So this is a system that is a gravity collection system. The influent from the tanks would come into this first tank here on the left. That is an equalization tank. So all the solids will be settling in tanks that are, let me take you to a better one. I'm sorry. Let me pop down here. This will actually show it to you a little better. Okay, there we go. The tank on the left is a gravity collection system. It's where all the solids settle in the first tank. It acts as a settling tank, or some may call it a septic tank. The solids stay in that tank or tanks, depending on the size of the system, and flow. The black water flows over into the second tank, which is an equalization tank. That is then dosed to the treatment plant, which is the third tank from the left. Shows the media. That's where it's all cleaned and treated at that point. And then when it comes out to the level that the state has specified that we have to meet, it goes into a pump tank. So from there, it's pumped out into a drip field in most cases. So going back to that article, I just wanted you to see this process and what's included. That's where this $2,500 to $3,000 per home system cost is at. That's what's included. It doesn't include like collection systems, lift stations, or whatever you may have before the treatment system. I just wanted to clarify that. This is just another process drawing. This is actually a process drawing of a large mixed use community we have in Utah. The BOD, TSS, and total nitrogen coming in is quite high. It's not residential, it's a mixed use of commercial and residential and hotels. But we're treating to a 10 BOD, 10 TSS, and 10 on total nitrogen. That's just a process drawing to look at there. The statistics show that within the US, 25% of existing residential real estate and 47% of new construction are served by on-site treatment systems, which is they're talking about septic tanks. Many of these systems are acknowledged to be inadequate with respect to soil absorption, nutrient removal, resource protection, and public health. Ironically, despite these demographics, the EPA policy changes, most regulatory codes as well as most municipal and commercial planning, continue to consider on-site systems to be temporary solutions awaiting a conventional sewer hookup. I wanted to just pause here for a second. When we do a lot of speaking with developers that want to take advantage of a system like this for their development, and many of them, including some engineers, have the idea that, well, these systems will go in and eventually we'll just hook it up to city sewer or gravity sewer that comes by the area. These are permanent systems. These work just as well and many times better than large municipal systems, depending on the construction and so forth of them. But these plants are not temporary. They can be temporary, but they're not meant to be temporary because they are a very high quality stainless steel product. The systems work well, they're designed well by engineers, and they will continue to work as long as needed. Looking beyond the traditional assumption that wastewater is simply a matter of safe disposal and the public health, the real contemporary wastewater issues are the economic and environmental issues in which the public has a primary interest. We're very concerned about environment. So when we build these systems, help the engineers design it, we try to take a lot of factors into account. Drinking water quality, of course, is extremely important. The deterioration of recreational water resources and other natural systems services. I don't know if you're seeing it in your designs, but it's getting quite hard to put wastewater into water in most states these days. They really try to stay away from it. That's why we're so busy putting in drip irrigation. Property values do go up with these systems as compared to a septic community. With a wastewater system, we see the property values go up about $4,000 by using a community sewer system as compared to putting septic tanks in the ground. The economic development in small rural communities advantage and interest or urban sprawl also. Decentralized wastewater management is not just about the disposal of wastewater and the public health. It has the potential to contribute to the formation of an infrastructure to sustain watershed integrity. Decentralized wastewater treatment is about the watershed agenda and the principles of community preservation and sustainable development. When approaches to the real wastewater issues are successfully accomplished, everyone benefits. Local communities win open space zoning. They have the natural systems are sustained through prudent zoning and reduction of non-point pollution. Developers win additional lots for development and higher margins, typically associated with conservation, subdivision, design, and municipal infrastructure. Regulation wins because it gains partners in compliance management, such as the municipality and perhaps a watershed authority. What that's kind of talking about is when we go into an area, whether it be a water provider that does wastewater as well, or a municipality, a lot of these systems, when they're put in, the developers are not in the wastewater business. They actually turn these over to someone like a municipality that they get the asset for free and they charge for sewer. So it becomes a real advantage to the municipality to work with the developer to put these in. They're getting the tax base, they're getting the assets, they're getting the sewer fees to help maintain it. So it's a win-win for everybody. Also, citizens and homeowners win because property values are enhanced with municipal infrastructure, water quality, supply management is improved, and economic development and quality of life issues are not restricted by infrastructure limitations, which they're talking specifically there about septic systems. There really are no major obstacles to decentralized infrastructure for wastewater treatment. New technologies in a properly managed context provide the opportunity for a land-based watershed initiative that could significantly reduce small flow point source discharges, such as those associated with on-site treatment systems. A decentralized wastewater management infrastructure should include clustered performance-based decentralized wastewater management systems, industrial and commercial pre-treatment prior to discharge to existing sewage treatment plants, wastewater reuse systems, We're almost to the end of this article. Actually, we can probably end it at that point. I guess this first, I'm sorry?
We do have a couple of questions if now's a
Yes.
good time for that.
Sure. You bet.
The first is, have you had any success in using your system to replace existing connections to municipal wastewater?
Yes, actually, we have. I'll tell you what. Can I address that down the road just a little bit, because I have to show something with that,
Sure.
if that's okay.
The second question is, who handles the permitting and inspection of these systems?
The permitting is handled by the state that you're in. So for an example, right now we have systems going into Texas, North Carolina, Utah, Indiana. So the engineer that is licensed within that state actually will do all the permitting paperwork with our assistance, the drawings and everything that they submit to the state. So the state will do the permitting. Engineer will submit, the state will permit it. As far as inspection, as far as installation, it's usually the engineer that's on site with us as this is installed. You know, they do their daily or weekly checks. And then we're there for the installation. We're also there for the startup to make sure that everything works correctly. Sometimes the state health department comes out, sometimes it doesn't, just depends on the state. For an example, they're there in Utah, they're here in Arkansas. They weren't, one of them was not there in Texas on an installation. So it really just depends on the state and how they work their, you know, their administration there and who does what. But we are there, the engineers there, the inspection. Now, if they're talking about inspection after it's installed, there are monthly labs that are taken on the treatment plant, and that is turned into the state, and they monitor it through monthly labs as well. So that's,
Okay.
I don't know if there's the question they're looking for, but hopefully that helps.
Okay, the next one is, are these systems allowed within a town's ETJ, or are they only allowed out in rural areas?
No, actually, Texas has ETJs, and they do allow these within the ETJ. In most cases, within an ETJ, that is, the system is turned over to the operating authority who's operating these. So again, every state is different. The only place I've heard ETJ, to be honest with you, is Texas. So this, I don't know if this person's in Texas or from Texas or has heard something, but I've not heard ETJs in any other state other than Texas. So if there is other ETJs, many times it is turned over to that operating authority by the developer to operate and collect sewer fees.
Okay. And then how successful have you been in getting municipalities in North Carolina to accept this as an alternative to tying into the town's sewer system?
Well, right now, North Carolina is our most active state. We're the busiest we've been in 22 years. We've been in business for 22 years, by the way. And right now is the busiest we've ever been. And North Carolina is our busiest state in the union. We're in at the present time, we're not turning, or nobody's turning systems over to the municipalities or to any townships that I know of. We've quoted a lot of projects. Other states, we've been successful in the municipalities taking over the system. I don't have an example in North Carolina right now, just because we don't have one going that direction. Most of it is outside of city sewer, being operated by, it's going to be operated by a local operator. So I don't have an answer for North Carolina specifically, because we don't have a project, I think, that falls within that realm.
Okay, that's all for now.
Okay. Just the last paragraph here. Estimates suggest that this infrastructure is achievable with technologies that require 50% to 70% less space. As I'll show you, our technology is a very, very small footprint. For citizens in small rural communities, these reductions represent opportunities to preserve water quality, to stimulate economic development and job formation, and to restore property values. Essentially, we are shifting from large sewage treatment sewage collection systems and centralized treatment plants to small and decentralized management systems. Keep in mind also that this is not alternative to centralized sewer, rather it is complementary adjunct to the existing infrastructure. So this is not usually replacing an existing municipal system, even though right now we have a couple quotes in right now to do that, but specifically it's not. This is an add-on where it's too expensive to bring collection sewer lines out. The city, the town, the municipality does not have that money, so they do rely on the developers to go outside of the city sewer to put these systems in. Again, they can keep them or they can turn them over to the municipality, and most times it's turned over. So it is quite a bit less expensive to do a decentralized system as compared to centralized throughout the community, throughout the outlying areas. It becomes very expensive with the cost of lift stations and big sewer lines and quite a distance of sewer lines. So what I wanted to show you, and I'm going to start out with something very small. Same technology, but it does have a video that I wanted to show you. So all of our systems are made out of stainless steel. It's a very high quality product. It's built in Europe and shipped to us. This is a single family unit, and we'll start at the smallest and then work our way up. It's a video I wanted to show you, and I hope you can hear. I don't know that you can hear the video, but you might be able to hear it. This is about a 1:30 video. It shows the operation of the technology. Even though it is small, again, it's the same technology as 100,000 gallons a day. So I'm gonna play this, and maybe can you hear that?
No, we cannot.
Okay, so what this is showing is the media. It's a chip media. It's where the biology attaches to. It's an MBBR in the first chamber on the left, membrane biological reactor. The second chamber is an SAF, or a submerged aerated filter. And this is an engineer who actually has this in his backyard. And he is testing the water. He's shut it off. He's testing the water. And he's going to put it next to a bottle of drinking water. This plant was designed for 10 on BOD, 10 on TSS, and 10 on total nitrogen. And this is without any methanol addition or anything. It's just through media. I guess I could probably make this bigger for you.
Side with side by side with a bottle of clean drinking water.
If you can't hear that, the bottle on the right is an unopened bottle of drinking water, and the bottle on the left is the wastewater treatment, 10, 10, 10 on total nitrogen. Just wanted to show that to you so you can see the type of technology that we have and what we're getting out of the system. But we can treat to whatever standard that you do care to.
Okay.
So what I'd like to show you at this time is, hold on just a second here.
We do have a question in the chat.
Yes,
Can these systems test for viruses such as COVID-19?
well, they don't, the system doesn't test it. Usually what they do is they'll test it prior to the treatment, because the COVID-19 would be in the waste, not after it's treated. So these systems don't actually treat it itself, or they probably wouldn't even treat it within the wastewater system. I would think that it would be treated prior to that in one of the settling tank or the equalization tanks, but not after. I'm not saying they can't, but I think they try to get as close to the source as possible, which would be, I would think, the waste tank, settling tank. They don't have a system or I don't have a system that actually would treat it through the treatment plant. I think that's got to be and again, I'm not that educated on how they do that. So it would have to be some type of a different a grab sample or something within the wastewater itself before it's treated, I would think. I wanted to show you what we actually use within the, and I think this is relevant. This is the media. The media that you saw was this media, the top right one. That's the one you saw in that small treatment plant. The media that's used in the larger treatment plants is this one right here. It has 3,000 square meters of surface area per cubic meter of area. What that means is it grows a tremendous amount of bacteria or biofilm, and it treats to a very high standard in a very small footprint because of this media particularly. This media back here is where they started many years ago. As you can see, there's only 440 square meters. As media developed in the industry, it went up, they got smaller, they got more surface area, and this is the media for the single family unit. This is the media for the larger treatment plants. Just so you have an idea of what media that we use within this. I believe we have a block media picture here. This is actually the block media that goes, it's a finishing media. So the first chamber has the chips in it. The second chamber on that particular one has this block media, and this is aerated, and it's a static media. It finishes the water down to the level that's required by the state. So I wanted to show you that media. We went through this a little bit earlier, but this is, I wanted to show you an RV and cabin park that we did in Alabama. And the reason is there's a lot of pretty good information on this page. That system right there is stainless steel. This is the treatment plant. It's 12 feet long by 7 feet wide. That's 25,000 gallons a day. That's how small the footprint is because of the media and the design within that system. So that exact plant showed up on the site looking like that. This is it being installed. The first tank you see back here by the fire truck, that's the settling tank. It's where all the solids settle. The black water then goes from that tank to this tank, which is the equalization tank, and that doses into the treatment tank right here, the treatment system. I want to get to the point where we get past that. There you go. That's it being installed right there. You don't have to use pea gravel, but you can. They chose to use pea gravel on that. Another picture of it being installed. This is looking the other direction. This is the equalization tank here, the treatment plant, and then this is the pump tank beyond it. And past that is the drip irrigation field where they're drip irrigating all the wastewater. These guys chose to put quite a distance between the two the different tanks. They don't have to be that far apart. It could even be a smaller footprint by putting them closer together. That's a picture looking back at the whole system. Alrighty. So that's the treatment portion of it. We have many different pictures that I could show you regarding, the treatment plants, what they look like. I guess we can probably go through a few here. This, for an example, is a 1,400 homes in Cave Springs, Arkansas. It's 92,400 gallons a day, the two of them combined. This is drip irrigation on a golf course. So this is watering a complete golf course. We have a second phase of this that was built as well. So combined, this one project has 412,000 gallons a day, and it's being dispersed to a drip irrigation, through drip irrigation onto a golf course. This is actually over here, on the right side, it shows the 92,400 gallon per day system, the tanks going in right before the treatment plant went in. This is a subdivision. I probably have a better picture of it on a different page, but this is a 212 home subdivision. And the reason I'm showing you this now is we're going to go to the collection side of this. This is on a step collection system. If you're not familiar with step collection, well, let me go through this first. The homes, as you can see, are along this very nice white river here in Arkansas. The treatment plant's up here in the left-hand corner. That's the treatment plant as well as the complete drip irrigation field. Drip irrigations, I believe, is about 8 acres, maybe 10, 8 to 10 acres possibly. But every home has a step system, and that's exactly what this is. A step system stands for septic tank effluent pump. This is an alternative to gravity sewer. On that particular system, where was it here? The treatment plant is up by the road. Everything here flows down towards the river. They didn't want to put in gravity collection and lift stations, so it was a modular build out for him. The developer built, so many phases at a time. He used a step collection system. At each home, there is a tank with a vault in it. So the tank looks like this. It's got 2 chambers. There's a baffle here in the middle, about 2/3 the way through. All the solids come in and settle on one side of the tank. And then there's a pass through in the baffle wall. Just the black water goes into the second chamber. And that is exactly where this product sits. This is a step septic tank effluent pump. So the water comes in the side within that second chamber, goes down to the bottom, comes up through the filter. As this fills up, the floats will float and activate the pump, which is right here. And the pump pumps only black water through small diameter pipe, 2 to 3 inch pipe to the treatment plant. Every 5 to 7 years, these tanks are pumped. And all you're receiving at your treatment plant is black water. That step system we're putting in and quoting in the answer to that first question that you had, retrofitting to existing systems. We have a system in Indiana that will be 800 existing homes that they're pumping to an existing treatment plant that's outside their city going to another city that's close by. So every home will have a step tank at their home. And one of the main reasons for doing that for retrofitting purposes is if you go into a city like that that has failing septic systems and try to put in a gravity collection system with lift stations, the destruction of what it does to the streets and the yards and the sidewalks and stuff is horrendous. So by putting in this small line, it's very doable. And directional boring underneath the street, underneath the driveway, the line from the house to the street is only an inch, 1 to 1 1/4 inches from the pump. And then in the street, it's about 2 inches. And as you get past 50 to 60 homes, then it goes up to a 3 inch. So these are very retrofittable to any subdivision. We have 6 that were 3 that we've already bid, and another 3 that we will be bidding in Indiana. And then of course this one 800 step systems that will be pumping to a larger treatment plant. So the retrofitting of these step tanks are very doable. It is called a low pressure system. There also is another product called a grinder pump that is a low pressure system. And we do sell grinder pumps. We just don't recommend them because the advantages to the step system is capacity for one. So when the electricity goes down, these tanks are about 1,250 gallons a day. There's a lot of capacity. If the electricity goes down in the neighborhood, you can continue using your water. And we suggest you use it wisely, don't overdo it, but there's a lot of capacity. With a grinder pump, there's not as much capacity, and the aftermarket cost on the products is much higher. So again, we do sell grinder pumps, but we do recommend in most cases the step system for low pressure collection. It does have many, many advantages over gravity systems. By putting in a step system, you eliminate all large pipe, large deep pipe, and any lift stations at all. It's all eliminated from your subdivision where you're putting these systems in.
Tom, we've got quite a few questions coming
Sure.
in about this. The first one, I think you've answered, but it says, I assume the equalization tank has to be pumped out and hauled off periodically. Please confirm, and if so, how often? And is that included in the maintenance costs quoted?
Yes, it is included in the maintenance cost. That was all included. And again, the maintenance cost that I gave you just out of memory was everything that is our cost as a maintenance company. So, my trucks, my insurance, just every possible thing. For that specific site though, to send someone out and do that type of maintenance, again, it's like once a week, one guy, they pump the tanks maybe on a large system, maybe every 2 years, depending on the usage. In answer to the equalization tank usually has very little sludge in it because it's just getting the black water. Most of the sludge, if it's a step system, for an example, step collection, most of the sludge stays at the home in the tank. If it's a gravity system, most of the sludge goes into the first tank, which is a settling tank. The equalization system eventually will have to have some pumping done, but there's not a lot of solids in there. So it's like maybe, I don't know, the settling tank may be pumped 4 to 5 times more often than the equalization tank. And even the pump tank on the backside will have a little bit of sludge, but very little. And eventually that may have to be pumped as well, but very, very small amount.
Okay, next question. Do you have any problems with low food value to the plant with step systems?
Actually, no. We have a plant. I showed you the 212 homes. In fact, let me see if I can just actually get to that. Hold on just a second. I might be able to show you that. The system for that particular project, I think I have it right here. Yeah, maybe I don't. I thought I did. Anyways, what we're seeing coming out of our step tanks as we test it is about 105 on BOD and 35 to 40 on TSS coming to our equalization plant or equalization tank. That's plenty of food for the treatment plant. We're getting single digit numbers on BOD and TSS. On that particular project, it's drip irrigation, so all they're requiring is BOD, TSS, and fecal coliform. Below, I believe, 4,000. So it's not a tough do. It's again, we're single digits, so we're seeing plenty of food coming to the plant. Even if it's gravity, though, remember that the solids stay in the first tank. The solids have to settle somewhere. So it's pretty much the same whether they settle at the home or whether they settle at the settling tank if it's a gravity collection system. It's pretty much the same what's coming into the EQ tank and going into the treatment plant.
Okay, do the step pumps need a backup power supply?
Well, they don't, but they could have. And I'll be honest, I've never seen a backup power supply for a step collection system. only because the tank has so much capacity for when it goes down. There's days and days of capacity. We recommend to our homeowners, you don't wash your clothes, you take showers less frequently, use the toilet only, regularly. So the water flow goes down substantially if the electricity goes out for a week or something like that. And we've had that here. We had electricity down for a week and a half, and the step tanks did fine. Usually, though, there is a backup source of power supply, a generator at the treatment plant that definitely can be added at the treatment plant, but normally at the home it's not. We haven't seen it anyways.
Okay. What could a resident of this subdivision expect to pay a monthly average for private maintenance of this system?
We have as I stated earlier, we do have a sewer company, and our monthly billing to our homeowners, depending on the subdivision size and technology and so forth, is $45 to $50 per month.
Okay.
And that we're seeing that's starting to be very comparable to municipal sewer. You know what they say in the city, sewer is less expensive and eggs are more expensive. In the country, eggs are cheaper and sewer's a little more. So it kind of works out that way.
Last one, best system if land does not perk.
Best system if land does not perk.
Yeah, PERC.
Okay. I don't know if they're talking about a single family or a larger system.
For residential.
For residential, say for a neighborhood. Well, I would say the discharge would be drip irrigation. I think that would be the best type of discharge system. As far as the treatment system, of course, it's what we're showing you of this technology. And as far as the collection on it, that would have to do with the lay of the land, how many homes, what the developer's looking for. But I think maybe they're talking about how to get the water into the soil, perking into the soil. And we find that drip irrigation is usually the best way to do that. In drip irrigation, about 80% of the water is used in the grass, into the foliage above it. So that goes up into the grass, and about 20% goes into the ground. So it's a lot of water reuse there, which is really, really good.
All right, that's everything.
Okay, all righty. Where are we? Oh, we're just about done. 47 minutes in. I'm just trying to think if there's something else here that, no. So I guess at that point, probably not a lot to talk about other than what this does. And I'm looking at this from a sales point of view, if I might do that, company selling. There's a lot of environmental advantages, I believe, to this, but as far as advantages where an engineer would have a developer come to him and want him to design a wastewater system or a subdivision, whatever, I think it's good that an engineer knows that these can be put outside of city sewer on land that is more affordable. We can get 3 to 4 homes to an acre, depending on the soils. There's a different type of collection system that actually can help save the developer money. On a gravity collection system, if you put in a 200 home subdivision, you pretty much have to put in the collection system for all the homes. It's all got to work together with the lift stations and everything. Where on a low pressure system like STEP, this only has to be put in as the developer builds out his phases. So if he does a phase of 50 homes or 25 homes, he's only got to put in a collection system for that amount of homes. And there's no lift station, so it's a very inexpensive install with PVC pipe for the amount of homes that he's building. And then the builder, whoever that may be, whether it's a developer, the developer sells the lot to a builder, the builder pays for the step tank and just rolls that into the cost of the home. It's very affordable. So those are things that an engineer could remember to talk to his developer and help save him some money and have a better build out as well. Well, I guess that's about it. It's almost 10:50 and I think I have till 10:50. Is there maybe any other questions or anything else that someone would like to see on the website that they haven't seen as of yet?
We do have another question. What are the advantages of this type of batch system versus a Clearstream or PureFlow type system?
Clearstream and PureFlow are, you can correct me if I'm wrong, they may have larger systems, but they're pretty much a single family unit. Advantages of this is we can treat to a much higher level on and I believe he's maybe talking about a single family possibly. We do have single family all the way up to, we're putting a 1.8 million gallon per day system in Utah in 2023. So we do have all different sizes. They are built custom. It is stainless steel. It's not polyethylene or plastic or fiberglass. It is a stainless steel product. The media is a huge advantage over these other technologies because we have so much surface area. Our product is so much smaller, and that allows it to cost less money because of the materials used to manufacture. So in most cases, we're more affordable than the competition on whether it's single family all the way up to big stuff. But the treatment level, again, I don't know that they can do a 10-10, 10 on total nitrogen, and we do that. So that's a huge advantage, single family.
Can you address quality assurance with builder installed step tanks?
Quality, can you ask me that one more time?
Sure. Quality assurance with builder installed step tanks.
So what we do, whether it's in Indiana or North Carolina or wherever it may be, Utah, we actually go ourselves, our project managers. I have 2 project managers, and they install, assemble the step tank. They put it together, the step inside the tank and the electronics and control panel. They do that on site with the builders, with the developers, installer. We make sure they know how to put these in, or we don't leave till they do. So the quality assurance, the quality of the product that we provide is very good quality. I mean, we can, I don't know how to tell you, it is good quality of hundreds and hundreds and hundreds of these in, but as the question I think is asking, the installation is really the key to putting these in, because we have had ones that were not put in correctly. So we are there to make sure that the installer installs 3, 4, 5 of these correctly when they're doing it. We're there on site. So when we leave, we make sure that they know what they're doing, if that answers the question.
Okay, what is the expected frequency and cost of media cleaning or replacement?
The media never has to be replaced, never has to be cleaned. In fact, I don't want anybody touching the media. That's where the magic happens. The media is the key to the complete treatment system. That media should never be touched. If you remember the video, on the single family, the first chamber was the random moving media, the MBBR media. The second smaller chamber was that block media that I showed you. About every 6 months on a single family unit, we provide a little air wand with the treatment system that hooks up to a little air valve. And all the operator has to do about every 6 months is to stick an air wand about 5 or 6 times down into that static media, the SAF, and hit the air and blow it out for 5 seconds. That literally is the only thing that we want done to the media, nothing else. It will last longer than all of us.
Okay. What percentage, sorry, are you ready?
I'm sorry, go ahead.
What percentage of the site area could a developer expect to lose to accommodate a typical treatment system?
Well, that depends on the soils. If you're going to drip irrigate, if it's going to be a water discharge, it's going to be a very small footprint. But if it's, say for an example, in Texas has terrible soils, 0.1 loading rate in most areas in Texas, which is 1/10 of a gallon per day per square foot, where southern Utah is 0.7. So their fields are 7 times smaller than Texas. So what we use when we're averaging something in a state that we don't know what that project's soils are, we use a 0.3 loading rate. So for an example, if you have, let me get my calculator here. If you have, I don't know, 100 homes at 350 gallons a day, that's 35,000 gallons divided by 0.3 divided by 43560 acre-wise, that's going to be probably 2.5 to 3 acres for 100 homes at 350 gallons a day, 0.3 loading rate of the soils. But again, to be accurate, we need to know what the soil loading rate is. If it's a higher number, a 0.4 or a 0.5, you're going to use less property. If it's a 0.2, then it's going to be a little more property that you lose.
Okay. Well, that is all of the questions that we have. Tom, thank you so much for your time today. Do you have any last words of wisdom for us?
No, just have a great day. Stay safe.
Great.
And thank you very much for this opportunity. I really appreciate it.
We appreciate you being with us. Everyone on the line, we have an hour-and-a-half break for lunch. If you are attending the full day, we will see you at the McKimmon Center. Our next session starts at 1:30. If you are a virtual only attendee, we will see you tomorrow morning. We do have a virtual coffee chat networking session tomorrow at 7:45. And then our first session will kick off at 8:30 tomorrow. All right, see you all soon. Bye-bye.